box on ramp, I believe. I have two classes who are roughly in the same spot, so it muddles in my head.
The last thing we did was the thing that had like a pyramid and two boxes and a rope in between.
Okay, how far did we get on that? We got a force diagram, we went as far as finding the acceleration.
Acceleration equals 11.
Okay. And
Leaving this.
then that's it. All right, that's as far as we got. So let's do a multi-part problem. All right, so problem number one. Frictionless. Not 40 degrees. Data. Equilibrium. Ideal rope and pulley. It's an equilibrium, find the angle. The ramp is part of the ground. Otherwise I would have drawn a solid line all the way underneath it. So what's the first step?
Force diagram.
There we go. Yep. The F up there. Since I really only care about these two masses, I'll put them down, but we can't do the whole thing. Well, we'll just do these two unless popularity demands. This is my 3, and that's the 6. All right, we're doing force diagram.
All right, we have gravity. Weight.
They are different weights, and so I will use different subscripts. There are a complete force diagram. There would be 2 arrows coming up on, they would be written on the ground, pointing upwards.
Tension.
Going which way?
Is that ideal rope?
Yes.
I think for the 3K will be going.
So the rope is pushing this down,
No, not lighter, but it's going up. And,
so the rope is holding it up.
FT3, no? Or you just gonna put FT?
It's an ideal rope.
Oh,
One rope, I don't need subscripts there. If I put subscript here and put FT3 and on the other one I did an FT6, at some point I need to acknowledge, since I'm actually solving it, that FT3 equals FT6. So with that, where's the other tension?
The top left of box 6.
Okay. If the rope were here, there would be an FT here and an FT there. Here an FT, here an FT.
So on the test, are we gonna have to, can we draw it like we're doing with the box, or do we have to do both arrows?
If it's just if I gave you this problem and I said, what's the force diagram acting on the boxes, then you only have to do this. If I want to do the full force diagram, I would provide the diagram for you. Just so that you know how I'm splitting it. Is the pulley separate from the ramp itself?
So,
This would not be for the test tomorrow.
okay.
This
So
is,
if you wanted both arrows, it would be like on the, I think it was the master set 4 and 5 on the applications part, you drew out the separate,
yes.
like the guide, the truck or something out, but you drew it out.
Yes, that would be, that's a case where I definitely want both of them. All right, we've got gravitational done and tension done.
There's a
Force.
normal force on the top right of the 6 box.
Is that it?
Yes.
Well, would you have a normal force with the 3 box coming off of the ramp since it's?
Is it touching the ramp?
No.
There's your answer. Justin?
None of the boxes are moving, right? They're just still.
I didn't say that, I just said that they're in equilibrium.
Is there
So it's sliding down the line.
It does not matter for actually solving the problem.
is there friction on the 6 box?
That's the symbol for no friction.
There is only that. There's no other normal force.
Okay.
There's no magically squiggling 0 or O. And then friction.
We just established. All right, in this problem, it is frictionless. If there were friction, then I would care which way it was actually moving, or if it were moving. Because if it's not moving, then the friction, we have to check to see if it's static. If it is moving, then that would tell us immediately which way it's gonna go. All right,
You can have that in after we solve it without friction.
all right, so what's next?
Acceleration.
Acceleration.
What about it?
In which direction
Okay,
is acceleration?
in which direction is the acceleration?
Right, about that.
So you agree with Micah? Would you say, all right, so Micah pointed that way. Now, in reality, what is the acceleration here?
0,
Why?
because the friction is 0.
Not because of friction.
Equilibrium?
Yes. Equilibrium, immediately. Acceleration is 0. The change in velocity is 0. The total force is 0. Equilibrium means all of those things, or if any one of those is true, the other two are immediately true. So what we're doing is establishing a convention here. I know the acceleration is 0. From a process point of view, pick a direction. Micah said, pointed like that. I'm assuming he was referring to the 6 kilogram mass, not the 3 kilogram mass. So if we're picking that direction, we should pick it in that direction. So now, what next? We've established sort of, I'm gonna call that acceleration, even though we know it's equal to 0, but it potentially will help us later.
Coordinates. Axes.
Okay?
We're gonna do. We need 2 of them, right?
Yep.
Okay. So for the one for the 3 kilogram one,
Yep.
have J hat being vertical and a horizontal I have in the right direction. Yeah. For the 6 kilogram one, we're gonna have the I hat be in the same direction of acceleration. And then that.
Okay. Sorry, since the kid's left toe, I don't have the eyes in the back of my head anymore. Yes, Jack?
For the acceleration, why did we say it was that way instead of the opposite direction? Or did we just?
It didn't matter, and I saw Micah gesture first, so.
Alright, so you could do it the other way as well?
Oh, yes, yes, you could. What next?
I was just gonna have a question of just, okay, so, does it matter which way is I and J, or do you just pick one?
As far as the perpendicular goes, it doesn't matter. J hat going this way or that way is completely irrelevant.
Okay,
No matter, even in the more sophisticated problems. As far as the other two go, I want them to be in the same general direction. So this thing, if it moved, it's either gonna go this way or that way. So I'm gonna pick my axes like that or like that.
okay.
And with acceleration 0, it's not critical, but if there were acceleration, which this would be the first part of a several step problem, if there were acceleration, then it becomes more critical, or you have to take something else into account if you don't do that. Did that answer your question?
Yes.
All right, any other questions?
It's time for the D.
Yes,
We don't need
we don't,
the D because we don't have any friction. Wait, hold on, what's D?
what's the next step?
Decomposition of vectors.
Do we need to decompose any vector?
I don't think so. Let me stop talking, I don't know what I'm talking about.
Would you need to decompose the 6 because it's not,
Decompose,
or the 6 kilogram box because it's not straight?
all right, so it's not a matter of the orientation of the object, it's a matter of the orientation of the forces. So remember, we have, this is our J3 hat direction, and over here, we have I6 hat and J6 hat. Are there any forces that are not perpendicular, parallel, or anti-parallel to my axes?
Yes.
Which one?
W6.
Wait.
So we have to break that up. We want everything to be, from the 6 point of view, parallel to the ramp or perpendicular to the ramp, so we break weight up. Now we've broken weight up before. There'll be a component down the ramp and a component into the ramp. One of them is sine and one of them is cosine. Which one is sine?
The one to the right.
Left. No.
Sine theta is going to be down the ramp, given that I gave you the angle with respect to the horizontal, and this is W cosine theta. So I'm making the claim that that pen will not work there. That this force diagram, what I have written in black here, is the equivalent of, I got a normal force this way, I got tension this way, I've got W cosine theta into the ramp, W sine theta down the ramp. This is the force diagram broken up for the 6 kilogram mass. Now the erasing wasn't brown here because that, you really should have weight there, or you should have these two components there. By having the components there, it made it look like I basically doubled the weight.
So we don't need to use the subscripts, when we use, or split it up?
Yes, we do.
Okay.
Thank you. Now what?
We gotta make some equations right now.
Okay. How many equations we're gonna make?
We're gonna make the dos minus. Two.
Yeah, yeah. Or you were flipping me off one of them.
3, 4.
So you're 5. Why 2?
I was thinking 2 objects, 2 equations.
And why are we thinking 3?
Well, I know we have 1 equation for the second box, and we might have, I think we have 2 equations for the 6 kilogram box.
We do. Why do we have 2 equations for the 6 kilogram box?
Because of the cosine, sine.
Yeah, we have 2 different directions here. Whereas here, we have only forces in one direction. Now, we identified I3 hat over there, but ultimately, there are no forces in that direction. And so if we did I3 hat equation, it would be 0 equals 0, which hopefully is not shocking. If it is, we probably should talk. All right, so what are my equations? So I got I6, J6, and J3.
Okay, so you're gonna take I6 is going to be weight subscript 6 sine O, or theta, and minus Ft equals mass times acceleration. Ooh, so close. M A M G M.
First off, what n is this?
Milligrams, no.
Kilograms?
No, not looking for a number here. We have 2 different masses.
M6.
Yes, M6. All right, times acceleration. Sure, I'll write acceleration here, but what is the acceleration?
0.
Yeah.
Does, no, that doesn't make sense.
What does that make, because if you're multiplying it.
Yeah, that's what I was thinking, but it doesn't make sense, because you still have mass, but you're still not moving. So multiplying it by 0 does nothing.
Yeah, I mean, well, wait.
Because the acceleration is 0.
Acceleration is 0, therefore this whole right side is 0.
Yeah, that's what I was thinking.
Yeah.
Is
Is that right?
But we still have mass, so how does that work?
It's whatever the mass is, it's 6 kilograms times 0, so it's still 0.
Okay.
Total force, they balance out. The tension, in this particular case, the tension is equal to W6 sine theta. It's also equal to W3. Yeah, I mean, if you recognize that this is equal to 0 and you just wrote down W6 sine theta equals Ft, that is a true statement. It's specific to this problem. Part of the reason why I went through this formality is the process. All right, 2 more equations.
Y minus weight 6 cosine theta equals math 6. And that's
These are forces,
oh,
but those would have units of newtons. That would have units of kilograms. Newtons to kilograms, not equal.
always.
What are we missing over here?
0.
Yeah, the acceleration, which is 0. Now, even if it were accelerating, this would still be 0 because it's not accelerating in that J6 hat direction. It's either going to accelerate down the ramp or up the ramp if it accelerates.
I have a question.
Yes.
Could it be W6 cosine 0 minus Y, because if Y is in the positive direction of J6, J hat 6,
Right.
could Y still be positive or, I don't know. I thought it was always a negative number minus.
No, it's, traditionally when I do it, I do the positive forces first minus the negative forces. If you wanted to do negative W6 cosine theta plus Y, as long as this is still a negative and that's a positive, it works. And since it's equal to 0, you can get away with a bit more, but again, the process. All right, one more equation.
Ft minus W3 equals M times 0.
M3 0.
Okay, so ultimately what we've come down to, right-hand side is all 0, just because it's equilibrium. All right, before we do that, we can kill 2 birds, 1 stone. What is the next step?
Substitution.
Do we have any formula for any of the variables here that are completely independent, that will always be true, regardless of what the problem is?
Yes.
Okay, what?
MG. Hold on. MG. Yes, sir. MG.
What am I substituting that in for?
Yes, I didn't mention that
Yeah.
part.
We know that weight is equal to mg, I hope we know that. So I can plug it in, and I'm now left with m6g sine theta is equal to the tension, and the last one, tension equals n3g. We would make a substitution there, but I know that normal force is not going to play a part at the moment. Now what? I'm solving for theta. Theta and tension are my 2 unknowns.
Set these equal to each other.
Well, could we just solve for friction by doing mass?
Tension.
Oh yeah, sorry. I saw the F.
Oh, do you want to plug in numbers now?
Yeah, I was just thinking if we just do M3 is 3, then 9.8 for gravity.
Sure, let's put it on Earth. So 3 times 9.8. 29.4. So I have 6 times 9.8 times the sine of theta